Let's do an example of this. Now, I was going to, is there a case when order does not matter and repetition is allowed? I want to say yes, but I don't know what that is off the top of my head. I'm sure I've seen it before. I just don't remember. So anyway, here's a combination example. Suppose we're at a charity event and the charity is being attended by 30 people. There's a $100 prize, and there are 3 prizes that are each worth $100. Yeah, like door prizes. We want to know how many ways we can give these prizes away, assuming no one can receive more than 1 prize. So, now, since the prizes are worth the same amount, order doesn't matter here. It's not like the person who wins first gets the bigger prize, and the next person wins the next prize, and so on. They're all the same, so order doesn't matter. The idea is you have 30 people, and you're basically coming up with a way to choose 3 of them without regard to order and not allowing repetition. Well, that's what the C of 33 is. So 30, 3, excuse me. If you do that, right? I mean, I'm using the formula. I could use that Desmos calculator as well. Same thing. In fact, let me just, what the heck, let me show it. I don't know if I have to, but, I really want to. I feel better doing that. You can also download the Desmos calculator onto your phone for free, which is nice. All right. Hold on. Here it comes. There we go. Okay, so if you do CNCR here, so when you first come into this, you're at main, but then you could press function, FUNC, then you go to NCR. So then you have 30, that's comma, then 3, and you get 4,060, as you can see. But again, is that function in a graphing calculator? I want to say yes, but I could be wrong about that. All right, so let me stop that. Let me get back to the notes. There we go. Okay, so we have this. Okay, so that was one example. I mean, you could also think of it as like with the race example we saw, where you have, I think it was like 8 people running in a race. First prize gets the one who finishes first gets a gold medal and stuff. Yeah.
Could you just explain how come it's like 30 times 29 times 28 times 27? Like, how come it is only a select few numbers and it just like decreases?
How I got the top up here?
Yeah, and the other one.
And this?
Yeah.
Oh, so basically this is the formula using here.
Mm-hmm.
So N in this case is 3, and R is 3. So if I substitute, we have 30 factorial, 30 minus 3, right?
Mm-hmm.
Factorial. And then we also multiply by an extra R factorial. As you can see.
Mm-hmm.
Okay. And then when I write out 30 factorial, this was actually another went over last time as well. You can write, it's really 30 times 29 times 28 times 27 times 26, and you keep on going. What you could do is you can rewrite it as times 29 times 28 times 27 factorial. You could do that. And
Okay.
that's actually good to do, because then what happens is these 27 factorials, they cancel. Factorial is the same as 6. I don't know if that helps enough, does it?
Yeah, it does. But how many, like, do you always have to stop at like the 4th number?
No. 30 minus 1 here, for instance, then I would have 29 factorial down here.
Okay.
If instead of 3, I had 1.
Okay, I understand now.
Sure?
Thank you.
Make sense, or?
I get it.
Okay, good. Okay, awesome question. Any other questions? Okay. So we had that example. So I mean, it's also, if you think about it, it's kind of like with the I think with the race, if I remember correctly, we had like 8 people running. The first prize was a gold medal. You know, the first person who finishes first, and then there was a silver medal, then bronze. So in that case, order mattered because the person who finishes first got the better medal, right? If instead all 3 medals were the same, say all 3 of them were gold, well, as long as you're one of the 3 people that finish, you're going to get a gold medal. So the order wouldn't matter there. So it's the same idea as here. Yeah.
Wait, so the 27 canceled from the numerator and the denominator, but what happened to, how did the 3 turn into a 6?
3 factorial is 6 because it's not just 3, it's factorial. So let me, yeah, I'm just thinking how to explain this. I have an idea. Let me see. This might help actually if I do this. So I'm just going to add a text box because I think I did email the notes as well. But let me just do this. So 30 factorial, right? Can everyone see this?
Yeah, I can see
Okay,
it.
good. Everyone can. Okay, cool. Equal to 30. Yeah, let me do this. Times 29. Let me do it this way. This might help. I make it look nice. So 29, right? Times 28 times 27. And then you keep on going until you get the 3 times 2 times 1. That's what 30 factorial is. And then what happens is with the 27 factorial, right? So that's what's on top here. So then, here, let me fix this.
Okay, that makes sense.
Sure?
Yeah.
What's going to happen next is this. If you do 27 factorial, that's going to be from 27 down, and that's what's going to cancel from the top bottom. And if you did 3 factorial, darn, messed that up. But then if you did 3 factorial, that's here. That's what 3 factorial is, but that's equal to 6. So.
Okay, thank you. That makes more sense now.
Are you sure?
Yeah.
I wanted to be sure. So I really want everyone to learn this. So I like the questions. So. All right, awesome. Okay. Any other questions? Okay. I guess let me keep that here. Okay, let me move on to the next one then. This one has to do with the lottery. Okay. Right. So basically here, I actually got this from another textbook, the one they actually use for Math 101, although I modified it a bit. So here, the lottery, you know, if you decide to play it, let's say, okay, this lottery actually, what happens is you have to choose 6 different numbers in any order you want, from 1 to 53, but 1 and 53 are possibilities. So there are 53 choices for each number. And of course, for the lottery to win, you have to get the winning set of 6 different numbers. So that's what happens. You buy a ticket, and I think on the ticket, you can either choose your numbers or, the numbers are chosen for you somehow. The first question is, how many different sets of 6 numbers can we choose? Well, remember, order, as I said, in any order, so order doesn't matter. And they have to be different numbers, right? So there's no repetition, and order doesn't matter. So we're going to have this here. Now, I did use this factorial stuff. I mean, you could just write out the answer from here to here. I'm just showing more work because I want people to understand. But if you had, like in your calculator, if you put this number in and then got the answer, that would be fine. could also use this formula if you want, which is what I'm doing. And then I just simplified it a bit to show how you get from here to here. Basically, what's going to happen is the total number of sets of 6 different numbers is this, as you can see. That's how many possible sets of 6 different numbers there are. Then, okay, so what's the probability of winning? Well, you have to get the winning set, right? There's only one winning set. So the probability is this. Like so. That's pretty darn low. That's what a lottery example is.